Hello, everyone. Today, I'm going to talk to you about computational linguistics. But first, a little bit about myself. Hi, I am Etienne. I am a software engineer. I've been working in tech for over 10 years. I love learning languages. I love learning about languages, and I care a lot about education and social issues. And I recently finished a master's in computational linguistics and in computer science. And during this master's, I developed an app called Polyglots, which I'm going to mention a little bit more later on. And I also work as a research engineer for the Institute of Applied Linguistics of Iraq as a consultant freelancer. Right, so let's get started. I think my slides are still glitching a little bit. Sorry about that. So I will just speak as I can. I don't know why this is happening. My apologies. It's showing fine on my screen. So just bear with me. I hope the slides regroup. But my plan today is to cover with you the following topics. First, what is computational linguistics and how it can be used? What is a language model, how it works, how it can be used in language learning, and then I'll give some specific examples of how I use it in my app specifically. And if I have the time, I'll also cover some career and resources in case you want to learn more about computational linguistics after my talk. Right. So the first thing that I want to cover, as I said, is what is computational linguistics and what is natural language processing and what you can do with it. So yeah, as the name hints, computational linguistics is a research area that mixes computers with language. So the idea is to get computers to do useful things with language and all of the several steps that are needed to create all of the language processing necessary, right? So that involves, for example, since getting the data, so crowdsourcing tools to gather data for analysis, then annotating and augmenting information, improving the data, right? So processing and adding manual information about the texts or the speech that we gather, then analyzing huge amounts of data, or creating statistical methods and for simulating and predicting things about language, and then of course creating the necessary applications with that. Let me just try to stop and stop sharing my screen and trying again, just hoping that maybe it will work better next time. But let me see. So as I said, doing all of the processing necessary to create, to investigate more about languages and create applications with it. So for example, you might have already interacted with plenty of these applications, right? Maybe when we think about computational linguistics, the first thing we think about is translation systems, which is the most common application of this research area, but also dialogue systems like mobile assistants like Siri or the Google Assistant, or the keyboard prediction, spam filtering, ad blocking, but also more simpler applications like counting words or doing grammar checks are also part of this tools that we consider part of natural language processing and computational linguistics. Before I move on, oh, it seems to be working now, the slides. Great, awesome. I hope it continues like that. But before I move on, I want to talk a little bit about what's the difference between computational linguistics and natural language processing, because those are two terms that you might encounter on the wild as if you go search for this on the internet later on. So, but to be brief, there isn't much difference, right? I am going to use these two terms, natural language processing and computational linguistics, interchangeably in the rest of the talk. I'll most often say NLP, just because it's shorter. But sometimes I observe some difference. For example, I could say that computational linguistics is more interested in using the processing methods, the computational processing methods, to understand more about language, while the NLP side might be more interested in using the linguistics knowledge to create useful processing applications, right? And so it's quite clear that these two areas kind of need each other, and this is sort of how they come to be used very often as synonyms. Right, so the field itself is a very young research area, right? Some people tied the beginning of it to the beginning of the research in artificial intelligence, right? Which was sort of starting in the 50s and the 60s, and that's when we came to things like the Turing test, which is a test to decide if a machine talking to you is a full artificial intelligence. And to do that, it must fake that is a human quite successfully, right? But I personally tie the history of natural language processing a lot further back than that. Because we have been doing computational processes with languages way before that. So normally when we think about computers, we think about numbers and number crunching, but the whole history of computers itself is very attached to dealing with language, right? So in the World War, we weren't just doing ballistics calculations, we are also trying to decipher encrypted messages, right? And we can even tie this further back to when Arab scholars first started using statistical analysis to decrypt messages, right? But conventionally, as an academic area, is understood to have started on the 50s and the 60s, and specifically with the first machine translation experiments, right? So around the time, it's when people first started creating rule-based systems for like syntactic rules. And that's when they first translated like a first set of like 60 Russian sentences automatically. And that was like a wonder for the time. You know, people were very optimistic. They were saying, oh, you know, in 3 to 5 years, machine translation is going to be a solved problem. And of course, 10 years later, they were still struggling with it. And today, we know that the area is still struggling with this because, you know, we use automatic translation and we know that's not perfect. And the reason why it's not perfect is that language is just very hard. It's just way more complex than people originally anticipated. It's a major part of what makes us human. And it's how can you make a computer understand it? Right? One important aspect of it is that it can be very tied to the knowledge of the world. So if I say a sentence like, for example, we saw the Eiffel Tower flying to Paris, and I ask, who is flying? You know, for a computer, the sentence is ambiguous, right? It needs to know, for example, that towers can't fly to answer this question. Right? And the problem goes deeper because sometimes not even humans know the answer to the question. You know, how if a human doesn't understand the language, how can computers do that? You know, for example, if I ask, Monica got the bath ready for her daughter wearing a pink skirt, and I ask, who is wearing the pink skirt? And it turns out that people don't agree on what is the correct answer for this. This is actually very highly influenced by the native language. So for example, in some languages, people prefer attaching it to the last reference mentioned. In other language, they will attach to the first reference of the sentence. So yeah, I mean, if humans can tell, how can computers do that? And you know, it's very tricky. So not everything can be answered through syntactic rules. So how do we deal with that? And one way of dealing with that is through statistics and through language models. So what is a language model? A language model is an statistic tool with one goal, to answer this one question: how likely is a sequence of words? Because then once you have this knowledge of how likely is a sequence of words, you can use that information to predict the continuation of a sequence. And that includes, for example, using the right words at the right time, right? Things like answering questions, for example, things like keyboard completion, all of those things, like they use language models. So how do these language models work, right? One way we can do that, and one of the ways these models used to be built, is by calculating how we transition from one word to another in a given data set of text. So for example, for a data set that has this one sentence, the cat in the hat, we can start making predictions based on how the data set goes from one word to another. And this, of course, has lots of limitations. You know, it can't gather bigger context than just one word. The other problem is that we can actually try to do that, but then it's very computationally heavy, and it's just not very practical to do this, and it won't be very efficient. One modern way of doing that is using something called word vectors. I'm just gonna give like a full intuition of it without going into the details of how this is built. But suppose we go through a giant data set of language, like the whole Wikipedia, and then we get all of the words and put it randomly across a graph. We just put it somewhere, right? I'm using 2 dimensions here. In reality, these models can have a lot more, but the way it works is exactly the same. We're just gonna put it randomly across some space, right? And then we start analyzing the language data, right? As we go through the text, we start moving these words around and kicking them around and moving them a little bit closer to each other as they appear closer to each other on the text that we are analyzing, right? So we do this multiple times, and we do this all the way through. We analyze all of the data sets. That takes some time. But in the end, we should have something like this. And the thing that happens is that words, they will naturally gravitate towards each other, and they are going to start forming these clusters that are very important in meaning. So we can notice that words like chair will get closer to verbs like sit. So they have this notion of similarity, right? And one thing I want to mention here is that this similarity doesn't mean that these words mean the same thing, right? But so it's not a notion of being a synonym, but a notion of being used in the same context. So for example, if I said, this movie is really good, or this movie is really bad, right? So good and bad mean very different things, but they would appear very close to each other in this type of model because they're used in the same context. So just to make this clear. And so once you have that, you can start making calculations based on the distance of these words in this graph. And the first time I learned about this, I was mind blown, because we can do things like calculating, for example, if you get the values for the word king, you subtract from that the values for the word man, you add to that the values for the word woman, and then with the resulting value, you go look for that in your space of random words. You're gonna find that the words that is there is the words queen, and this looks like magic to me, and I love this. And once you go through an actual whole data set and use a real model, you're gonna end with something like this whole infestation of words forming these clusters. And if you want to play around with it, there is this website, dissected.it. You can type in some words. You can see how close, how far they are to each other. It's very interesting. And if you have some programming skills, you should check the website Towards Data Science, because they have full tutorials on how to build a model like this yourself. One thing that I want to notice is that, just calling an attention to something, is that these models are not intelligent, right? So there are state-of-the-art models like GPT-3, and they use a little bit more advanced techniques, and you can create, very human-looking chatbots with this model. The intuition of how it works is the same. So what I want to call attention here is that what it's creating is just a sequence of words that is likely to exist. It doesn't mean that it is correct or that is true. It has no notion of the world exactly, right? All it can do is give a likely sequence of words. And it's important to have this in mind, because we know that language can be very dangerous. We know that language can be used for harm. And when we combine that with technology, we are weaponizing all of the harm that we can do with language. So I really want, if you forget everything I mentioned about the talk today, I really want you to remember this one thing today, that these models, they're not ready to be used with any kind of application without excruciating, detail-oriented hunt for social problems, right? This needs to be in the mind of anyone using these models all of the time. If you want to find more about these types of issues, I recommend following Emily Bender on Twitter. She's a researcher in the area who's very focused on the ethical issues of language technology, so I recommend following her. But yes, these models, they should not be used in just any application, right? So this is actually a real interaction that happened when people were testing were testing this GPT-3 model. Right. So given that, can it be used in language learning? How can it be used in language learning? So there is a research area in computer science called computer-assisted language learning. I'm going to say CALL from now on because that is just too long. But not everything that is NLP is useful in CALL. Not everything that is CALL is used in natural language processing. But there are some uses that can be found in both. Because, for example, computer-assisted language learning doesn't necessarily need to have some of the processing. Because, for example, I can be creating a tool that makes some resource available on a website that was from a textbook. There isn't necessarily machine learning or anything fancy happening there, or any fancy programming, right? But some of these uses can be, for example, concordancy, which is when you try to find the same word in different kinds of texts. So we have different examples of different contexts that word is used. And then you have the opposite of that, which is the alignment, which is when you have the same context but different words. And that is used, for example, in different languages in applications like Linguistic, for example, so you can know exactly what to say for the same context instead of going for like exact translations of a word, right? So you get better examples. Other uses are lemmatizing, so reducing the word to its root form. So you can, for example, look for it in a dictionary in a reader application. But of course, the goal, the gold ideal of the research field of computer-assisted language learning is being able to parse learner inputs and provide insightful feedback, right? And I don't mean just identifying that you made some grammar mistake or some spelling mistake, but actually knowing why you made that mistake so it can fix the problem, right? So it can teach you exactly what you should learn so you don't make that mistake again. And that is something we're just not there yet, right? There's lots of research going on right now on how to use bots and fancy machine learning for language learning, but very often they are perceived as, very cool and like a novelty, but not particularly useful. And the reason is that to do something like that, first, a bot needs to pass a Turing test and fake everyone that, beyond everyone that it is a human, which is something that technology hasn't done yet. So, yeah. And then, as I said, it can't just spot the mistake. It has to diagnose why you made a mistake, right? One other problem is that the research in NLP is overwhelmingly focused on English, and that makes it less useful in a context where we are looking for applications that are multilingual or that deal with multiple languages, like the case of language learning. One other problem in the area of computer-assisted language learning is that the intersection between SLA, I forgot adding what SLA, second language acquisition research, language learning, is that the intersection between language learning and call is also small. And there are two reasons for that. One of them is that a lot of the learning, of course, as we know, happens outside of the scope of special tools. So for example, I have the whole of the internet to chat with people. I can read a book. I can watch some Netflix. I can knock on my neighbor's door and have a conversation, right? So there is a lot of learning that happens outside of some material that is specifically designed for learning. The second problem is that there are fundamental differences in the motivation of the research and the audience of the field of the linguistics field that deals with language learning and the computer science field that deals with creating language learning applications. Because one of them is very teacher and pedagogy and education and formal classroom oriented, right? The audience of that research is a teacher who is consuming that research and use the advancement in the science of language learning to create better learning materials for their students. There is also some, I'm not trying to discount the fact that there is research that deals with learner-centered studies, but there is very recent in terms of the history of research in this area, right? It's a very young area of research compared to all of the long research in language learning. So the overwhelming majority of the research is focused on teachers as an audience and environments where you have the presence of a teacher. In the meantime, when we're creating computer applications, we're handling the possibility of infinite accessibility, right? So we are dealing with situations where a teacher is not necessarily available, or maybe it's unaffordable. Maybe people just don't have money to pay to be in a formal classroom, but they have a phone with some 3G internet, right? So the fields of application, they have less intersection than what we imagine because they are designed for different environments. So how do we deal with that in computer applications, right? The tech is not advanced for some things, and the research is not very advanced for doing some things automatically. And the answer is giving up. So we give up of doing something automatically with computers and we fall back to humans, actually. And just as an example, this is something that Duolingo does, for example. When you make a mistake during a lesson, it can't tell you why you made a mistake, but it has the comment section. And this is, in my opinion, the most useful feature in Duolingo, because when you click on the comment section and you see people discussing about that exercise, then you can understand why you made a mistake, right? And to some extent, this is also what I do in Polyglots. So the corrections in Polyglots, they are also dealt human to human. Before I continue on how I use computational linguistics in Polyglots, I want to tell you what is Polyglots, because as I said, this is the app I developed for my master's project. It's not some famous app, so you might never have heard of it. So I'm gonna take a short time to just say what it is, right? So when I developed Polyglots, I developed it having in mind that I wanted something where people could practice communication before they were fully comfortable joining a full conversation, right? So it's a collaborative environment where people can play with each other, an image guessing game. So you can talk about an image and the other person can figure out what is the correct image, right? So we have total freedom to write. So there isn't like a fixed correct answer to an exercise and you can only type that. No, you have freedom to be creative and express yourself in the language, but at the same time in a very low stakes and low stress environments, right? Your only purpose is to get the message across of what is the correct image. And because it's all image based, there is no intermediate language. You can play it in any language at all. So far, it has been played in over 40 languages. And you can download it for iOS, which is still in beta, and Android. And the link is that one, polyglots.app, and you can go there to download it. Right. So given that, how do I use computational linguistics in Polyglots? And I used it in two instances so far. The first one was evaluating and correcting, because if there isn't a correct answer, then how do I know if what you're writing is correct, if you're getting better at the language? And the other issue is generating tips. So the first one, as I said, people have lots of freedom to write whatever they want, right? So sentences can be very simple. They can use some simple expression like here is, so some very formal-like structures like here is your dinner. Some people create trivias. They can say it is birds, but it can't fly. So it doesn't have, for example, a name of the object. Some people create like multilingual jokes. This is one of my favorites. A friend of mine sent this one to me. It mixes Portuguese with Spanish in a Brazilian rap song. And some people just go nuts, talk about their daily lives. And so, the scope is incredibly varied, and there isn't a simple way to evaluate that. And this is where I use language models, because as I said, a language model has the goal to say what is a likely sequence of words, right? Because it does that, a good model should assign a real text in that language a very high probability, right? So what happens when you're dealing with learner language? When people have some mistakes, when people use the wrong word order, when people conjugate it's wrong, if something seems off, what happens is that this manifests as a lower probability of that sentence existing in that language, right? So my first research question was to see if this was actually happening, right? Which it does. So if you want to read more about this, I wrote a paper after my master's called Polyglots, a Conversational Agent for Language Practice. But to sum it up, what I did was this. I used the language models to investigate learner language. And as you can see, there is a very huge difference between this average score of people who identify as beginners in a language and people who are natives. And also as expected, the difference between people who say they have an advanced level and natives is not that big. And also, luckily for me, I also tested how people were going with their scores as they play Polyglots, and it works because the scores increased according to the number of rounds. And yes, so that's one instance where I used natural language processing methods in the app. The other instance was on generating the word tips, because I process all of the data sets of the player's text in the history for a given image, and then I do some simple processing like spell checking, removing profanities if there is any. Then I count the most popular words, and then I use a software for tagging that separates them in categories, because, for example, I don't want to provide just nouns, right? I want the tips to be helpful for people to construct a sentence. So it's more useful if they have one verb and one noun instead of 3 nouns, for example. So I always provide one noun, one verb, one noun, and then something else. Then it can be like an adjective, an adverb, another noun, or something else. But the first 2, they are fixed in terms of parts of speech, in terms of the function in language. And I also do some personalization, so I check against the history of the player, so I can suggest words that they have not used before. And this isn't available for every language, because this is something that I have to process for every language. Unlike the language model, I could use a multilingual model and just evaluate the score for everyone. So this in Polyglots is available only for English, Portuguese, French, German, Spanish, and Italian. I think that's, I don't, there is a list on the website. You can check it. But yeah, I'm not sure if we're gonna have time, but I want to briefly talk a little bit about career, about how you can learn more about this after this talk if you want to. So there are some common paths on how you learn more about computational linguistics, and the most traditional one is, of course, academia, but you can also do boot camps and some self-study. If you want to find something where you're going to find more related knowledge to it, and that you can commonly find in courses and in boot camps and on the internet, learning data science is what is going to get you closer to this topic of computational linguistics. So data science does have some introduction. The common courses on data science have some introduction material on this research area. And then there are, of course, things that depend on your background. If you have programming skills, then you have to learn more about linguistics, right? And if you have linguistic skills, then you have to learn more about programming. And this is typically done in academia through, you take an undergrad in one and then a master's in the other one. So this is sort of what I did. So I have a software engineering background, and then I did the computational linguistics in the master's. And then I had to learn a lot of linguistics while I was doing that. This is the path that I sort of recommend, not only because it was my path, but also because career-wise, it's very interesting, and the technology part is always changing, so it's good to have like a foundation, a solid foundation on that. But all of these paths are valid, and you can find free information on all of this on the internet if you want. On university, you can find, sometimes it's difficult, computational linguistics course directly. But depending on what you want to do, for example, if you want to do research, you are still going to need a master's anyway. So it's, I don't know. I personally don't know anyone who did one course that was specifically on computational linguistics. Everyone that I know either self-studied or did the switching that I mentioned in academia. All right, so where can you learn stuff for free? I selected some resources here. I'm gonna put the slides on the internet, so don't worry about writing it all down now. I'm gonna put it on my Twitter. So if you follow Polyglots app on Twitter, I'm gonna post it there. So don't be too worried. But I just wanted to mention that these resources exist, and some of them are amazing. So, and of course, it depends a little bit on your background. So if you still need to learn programming, I recommend the Free Code Camp and the computer science open source university course that you can find on GitHub. If you need to learn more linguistics, there's the book Essentials of Linguistics that you can find free on the internet that is also excellent. My favorite resource is the book Speech and Language Processing, because it goes very deep. It's the book I use more on my master's, and it goes very deep into both areas, both the linguistic side and the computational side. And the lectures of NLP with deep learning on Stanford that are all on YouTube, and they are excellent. What else? Oh, the Hugging Face. So Hugging Face is a company that does open science in this area, and they have a giant community and lots of resources and podcasts, and it's excellent. So I recommend checking them out as well. Right. So wrapping up, I hope today you learned what is a computation, what is a language model, what is language computational linguistics, and how to use it, how it can be used for good and evil, and paying attention to that, how these techniques can be used in language learning applications, and where to find more about this after the talk. So I hope you enjoyed. Thank you so much. Time for questions. I will be on the chat afterwards if I don't have time to answer them all now. Or you can just go find me on Twitter and send me a direct message, and I will also answer them over there. Right, so let me look at the questions. What programming languages would be good to know to do CompLing and NLP? Python. Python is the one I recommend. Sometimes when people come from a data science background and they might get introduced to R, which is a very statistical tool. But if you want to deal with language, the most common one, the one you're going to find more free resources to learn is Python. Second question, is some kind of software robot that will be able to talk with language learners soon realistic? I do not mean Siri, etc. I think this question ties back to what I was saying before, that to be really useful for language learning, this robot would have to be able to diagnose why you made a mistake. And we are very far from that. In my opinion, this will take a while. You mentioned some of the ethical conundrums facing developers working with computational linguistics. Could you share some more real-life examples of how the technology can be unethically used? Yes. One problem is in translating, and how these models, when they're used in translation, they can attach bad information to a place where previously there was no information. For example, some languages, they don't have genders. They don't have gender articles. I can't remember of one example now. Wait. Finnish? I think Finnish does not have. Turkish? I don't remember of all of the examples now, but some languages, they don't have gender articles. So they are like English, where they have just, in English we have just the, but some languages have the same for like he or she. right? They only have one article for that. So when you are translating from a language like English that says he is an engineer to that language, there isn't much of a problem because then we just use the neutral pronoun that they have. But when you're translating the other way back, so the language has a neutral pronoun and you're translating that into a language that does have a gender pronoun, and you have to pick between he and she. So these models, they will just pick the one that is more likely the one that has been used more often. So you start having these problems where you translate a sequence of sentences that are completely neutral, and the result will be he is an engineer, she is a teacher, he is a doctor, she is a nurse, and so on and so forth, right? So start dealing with things like sexism. From humans, they penetrate this, it very insidiously goes into these models, and this can happen for any human bias that we have. When mining for input, is no native content typically included? That depends. That depends on the model. Normally, most of the data sets they're using in research, they are not going to include learner language. They are going to be not necessarily native, but they are going to be like standard versions of the language. So for example, I'm going to crawl all of the Wikipedia. I'm going to crawl a bunch of websites that have text. And normally when I publish a website, I am going to correct things before I publish. Unless I'm dealing with data sets that have chat language, but those are not typically included in many systems because of the ethical concerns also with privacy, right? We have to deal with things like GDPR, for example, and that has where you have to be able to remove the data from the model at any time the person wishes to. So it's very complicated to deal with some data that is more personal, which is the data that is likely to have non-native content, right? So data that is public facing usually passed through some steps of correction, which is why what I mentioned before, that learners' language will typically manifest as a smaller probability of existing in models created with these data sets. I guess this was all of the time I had for questions. So thank you so much. If you have more questions, I'll be in the chat for now. Check Polyglots out and give me feedback. I would love that. And yeah, see you soon.